Hello and welcome to my video. This is the demonstration of Prim's algorithm based on the basic OpenGL and GLUD and simple libraries. So let's make some vertices. There is some hint on screen. So whenever I press the right click on my mouse, left click on the mouse to create vertices. So A, there's a cat texture inside that circle. The cat looks pretty. A, B, and C. Let's make a triangle. The age, let's say 1. From there to C, let's say 2. And from C to A, let's say 3. And whenever I press P on my keyboard, it should show my minimum spanning tree. So how it works is Prim's algorithm is basically straightforward. It picks the edge with minimum cost. So from A to B, so it has minimum cost. So at first it picks A to B, and from all the vertices connected to AB edge, it picks the another minimum. So the another minimum is not AC, it's BC. So here you can see those red and changing color edges are my minimum spanning tree. Let's try some other graph. Let's make a square. Now let's make a square. A, B, C, and D. From A to B, let's say 1. I like to do basic. And from B to D, let's say 2. And from D to C, let's make 3. I'm trying with a simple example here. From C to A, let's make 4. Okay, whenever I press P on my keyboard again, I should get my spanning tree, and it's a minimum cost. I can guarantee that because A to B cost 1, B to D is 2, and D to C is 3. Of course, this is the minimum spanning tree, and the total sum of cost is 6. 3 plus 2 plus 1 is 6. So I'm pretty confident on my algorithm. Let's try some bigger graph to test the complexity of the algorithm. Now let's try with some bigger graph and let's check out our algorithm. So I'll make the vertices and edges really quick. I'll give some weights to this graph and I'll verify whether my algorithm is correct or not. So I've completed my graph and all the edges with the cost. You can see the cost on the right hand side of the window. 10, 25, 22, 12, 16, 28, 14, 18, and 24. So my algorithm should compute the sum as well of minimum cost and the minimum cost spanning tree. Let's see. So I pressed the P on my keyboard. So now it computes the spanning tree. So the algorithm is really straightforward, as I said before. It picks the vertices with the minimum cost, and AB has minimum cost. The edge is AB, so it picks this edge first, and it picks all the edges connected to this vertices. So now not this AC, not AC. It's 28. So this is 28, and this is BG. BG is 25. So this is less. So it picks BG. From BG, it will not pick GD because uh, it's 24, and GF GF is 22, so this will pick the minimum. This is 22, and from this age FD to FE, so 18, this is 18 and this is 12, so it will obviously pick the smaller one. So this is the 12, this the cost is 12 here. Again, same goes here. So the algorithm is simple. It picks the age with minimum cost, and for so now let's try with disconnected graph, the graph where there is no connection between ages. What the algorithm response, let's see. So I'm constructing some disconnected graph. Let's say A, B is some random. I'll say 100. And let's say C to D. C to D as 20. Now if I execute my algorithm, it says graph is not connected, cannot compute MST, because in graph must be connected in order to satisfy condition of Prim's algorithm. So you cannot get Prim's algorithm in disconnected graph. So thank you for being with me, and have a good time. Bye.